Example 6. Write the form of the partial fraction decomposition of the rational expression. Do not determine the numerical values of the coefficients. All right, so what I have prepared in example 6 are 6 rational expressions that we are just going to set up the partial fraction decomposition for, okay? We will not solve for the coefficients. We are simply practicing how to set these problems up, okay? Because oftentimes that is the most difficult part of the problem, okay? So we are just setting each one up for partial fraction decomposition. In part A, we have x squared minus 3x plus 5 over x minus 2 quantity squared times x plus 4. First thing we need to do is look at the degree of the top and compare it to the degree of the bottom, okay? The numerator is degree 2, and the bottom is x minus 2 squared, so it's being multiplied by itself, and then we have to multiply that by x plus 4. So to figure out what the first term or the degree of this thing is going to be, take all the x pieces and multiply them together. It's going to be x times x times x. This is going to be x cubed, so the bottom is degree 3. Okay, so that means that to do the partial fraction decomposition on this particular expression, it's going to be one of the cases, either case 1, case 2, case 3, or case 4. We do not have to begin with long division, okay? All right, so let's examine the denominator here, okay? That's what we use to figure out the case, okay? So we have x minus 2 squared, so that means it's multiplied by itself, and then we have times x plus 4. Okay, if we look at each of these factors, okay, they're all linear. The highest power of x in each one is the first power. Okay, so what we see here is we have linear factors and we do have repetition. Okay, this x minus 2 appears in the factorization twice. Okay, so we do have repeated factors. Okay, so this is going to be case 2. Okay, where we have repeated linear factors. Okay, so all we're going to do here is set up the partial fraction decomposition. Okay, so to do this, I am going to, I'll just start writing right here. Okay, so I am first going to handle the x minus 2 squared. Okay, do not let that second power throw you off. This, yes, if you were to multiply this thing out, you would end up with something quadratic, but as it's written, the factor inside the x minus 2 is linear, okay? It is repeated because it's multiplied by itself, okay? So since the highest power of x minus 2 is the second power, we're going to see this x minus 2 part is going to contribute to 2 fractions. Okay, so the first fraction will have a denominator of x minus 2 to the first power, and then when we tack on the next fraction, it will have x minus 2 raised to the second power. Okay, so that's what that is going to contribute. Both of these denominators, the factor itself is x minus 2. Okay, it's linear, so that means the numerator has to be a degree less. So the numerators here both need to be degree 0. So they're just numbers. So we're going to put an a here and a b here. Okay, we're not done because we need a fraction for this factor. Okay, so x plus 4 is raised to the first power. It's not a repeated factor, so we're only going to get one fraction out of this guy. So the denominator here will be x plus 4. It is degree 1. That means the numerator will be degree 0. So we're going to have to use something that we haven't used yet, which I'll use c. And we're done because, again, the x plus 4 is not repeated. Okay, so this is how you would set this one up, okay, for the partial fraction decomposition. And then you can go about your business to solve for the a, b, and c if you wanted to. Okay, again, we're here we're just practicing setting these things up, recognizing the case, and then setting up the partial fraction decomposition. Okay, all right, in part B, we have x squared over x minus 3 times x squared plus 4. Okay, we need to begin by comparing degrees. Okay, the top is obviously degree 2. In the bottom, if we were to FOIL this out, this would be degree 3. So we're good here. This is going to be one of the cases. Okay, we don't have to use long division here because the degree of the numerator is less than the degree of the denominator. Okay, so let's take a look and focus on the denominator here. Okay, it is already factored for us. One factor is x minus 3, the other is x squared plus 4. Okay, this factor right here, the x minus 3, it is linear and it is not repeated. I only see it once in the factorization. Okay, when I look at this other factor, look inside the parentheses. Okay, inside the parentheses, we have a square. It's x squared inside the parentheses. So this is a quadratic factor. Okay, it does not break down any further. Like I said, this is a sum of squares. I square x to get x squared, I square 2 to get 4, but we're adding them, so the sum of squares does not factor. Okay, this is irreducible. Okay, it is also not repeated. Okay, because I don't see this factor squared, I don't see it cubed, I don't see it raised to the 4th. None of that is going on. Okay, so this is an irreducible quadratic factor. Okay, and it's not repeated. Okay, so when we set up our partial fraction decomposition, okay, we're essentially going to have two fractions that we're adding together. The first fraction will have as the denominator the first factor, the yellow guy. Okay, and then the second fraction will have the remaining factor as its denominator, the x squared plus 4. Okay, each factor produces one fraction because neither factor is repeated. Okay, so as far as what goes in the numerators here, when we look at the first denominator here, the x minus 3, that's a linear factor. It's degree 1, so you have to go down a degree. So in the numerator, we will just have a number a. Okay, when we look at the other fraction, the denominator is x squared plus 4. That is quadratic, degree 2. So the numerator has to go down a degree. We need degree 1, so something like mx plus b. So we're going to have to use different coefficients. You don't want to use a here, so we're going to put bx plus c. That's it. It's set up. Okay, that's your answer. Okay, let's move on to part C. Okay. In part C, we have x cubed plus 4 over 9x cubed minus 4x. We need to begin by comparing the degrees, okay? So this is pretty easy to see. Both the top and the bottom are degree 3. The highest power of x in each piece is degree 3. This is a case where the degree of the top is equal to the degree of the bottom. So this is one of the circumstances you have to perform long division on this fraction before you set up the partial fraction decomposition. Okay, so we're going to do that here because it's part of setting this thing up. Okay, so we're going to take x cubed plus 4. Okay, that's what's going to go under the division symbol, but we're missing a couple of the places. So we have to have a placeholder for x squared, we have to have a placeholder for x, and then we have the plus 4. And into this, we need to divide the 9x cubed minus 4x. Okay, all right, so we need to begin by comparing here. What do I need to multiply 9x cubed by to get x cubed? Okay, so that's kind of weird. Okay, what do I need to multiply 9x cubed by to get x cubed? Well, the answer is going to be 1/9. Okay, so this is just a number, so I'm going to put it over the number term. Okay, so then I need to do 1/9 times the 9x cubed minus 4x. Okay, this is going to give me x cubed minus 4/9 x. Okay, so this is a little bit strange. So we're going to have, this is going to turn into x cubed minus 4/9 x, which I need to put under here. Okay, I'm keeping things in their columns here. Okay, so I need to subtract out now. So if I subtract out my result, that means I need to change the sign of everything. So the x cubed will change to negative, as will, well, I forgot to bring the minus sign here. This should have been negative 4/9 x. So this guy will change to plus. Okay, so x cubed minus x cubed, those guys go away. Okay, if I bring down the 0x squared, that's just going to be 0. And then I'm going to have 0x plus 4/9 x, that's 4/9 x. Okay, and then I can bring down the 4. Okay, you will now ask yourself, what do I have to multiply 9x cubed by to get 4/9? Okay, and that's not possible. We have to stop here because the degree here is 1, but the degree here is 3. Okay, because the 4/9 x plus 4 has a smaller degree, we need to stop. Okay, so what we will conclude from this, okay, we can conclude we started with x cubed plus 4. We divided this thing by 9x cubed minus 4x. Okay, and so this is going to give us, the result was, it went into it 1/9, okay, plus 4/9 plus, or sorry, 4/9 x plus 4, okay, over 9x cubed minus 4x. Okay, so this is what this thing looks like. Okay, I know it's weird. If you look at it, what's left, this fraction, it has, the numerator is degree 1 and the denominator is degree 3. Okay, so we're going to be able to do partial fraction decomposition on this guy because the numerator has a smaller degree. All right, so before we proceed, I'm going to try to make it nicer because it's weird that we have that fraction in the numerator. So I'm going to make this 1/9 plus, in the top, I'm going to combine this into one fraction. This is going to be 4x, because this is 4/9 x, plus 36. Okay, 36 divided by 9 gives you the 4. Okay, and this is going to be divided by 9x cubed minus 4x. Okay, and so then if I just divide fractions, like this is over 1, if I just divide the fractions, this is going to be 1/9 plus 4x plus 36 over 9 times 1 over 9x cubed minus 4x. Okay, so basically this is 1/9 plus 4x plus 36 over 9 times 9x cubed minus 4x. Okay, so it's a little crazy. Okay, so going back to the original problem. Okay, from the long division, we know we can write this guy as 1/9 plus this simplified guy down here. Okay, so 4x plus 36 over 9 times 9x cubed minus 4x. Okay, so the second fraction is what we're going to have to do the partial fraction decomposition on. Okay, we can leave the 1/9 alone because it's just a number. So I am running out of room here. I'm going to jump to another page so I can explain this in more detail. All right, let me write down where I started and where I am now. Okay, so I started with this single fraction x cubed plus 4. That's the numerator. Okay, so x cubed plus 4 over 9x cubed minus 4x. After doing the long division, we know this is equal to 1/9 plus 4x plus 36 over 9 times 9x cubed minus 4x. Okay, so it's going to look like this. Let me double check it to make sure that's right. Oh, it's minus 4x. Okay. All right. So, like I said, okay, we do not need to do a partial fraction decomposition on the 1/9 because that is a simple fraction. We can perform it on this fraction because the degree of the top is 1 and the degree of the bottom is 3. Okay, so since the degree of the numerator is smaller than the degree of the bottom, we can set up a partial fraction decomposition here. Okay, so to do this, I'm just going to carry the 1/9 here. Okay, but what we're going to do here is if you want to go ahead and factor out the 4 from the top, you can. It's not necessary. But you do need to factor the denominator entirely. Okay, so if you notice, you're going to have a 9 right here. Okay, and then you can take out an x. Okay, and then this is going to leave you with 9x squared minus 4. Okay, and it actually factors again because now we have a difference of squares. I see you can square 3x to get 9x squared, and you can square 2 to get 4. Okay, so this is going to be 1/9 plus 4 times x plus 9 over 9x times, then you're going to factor the 9x squared minus 4. Okay, so this is going to be 3x and 3x. 4 factors into 2 and 2, and if you remember the rules for the difference of squares, you have one sign of each. Okay, so this is what this looks like. I know it's crazy. Okay, so when you look at this, you have 3 linear factors. Okay, I see 9x, that's one of them. Okay, so this is really like 9x plus 0. Okay, so that's a linear factor. And then I see the 3x plus 2, the highest power of x is 1. And then I see a 3x minus 2. Also linear because the highest power of x is 1. Okay, so what we will do here is we will retain the 1/9. Okay, and then each of these factors is linear, so each of these factors will go in the denominator. None of them are repeated. Okay, so that means each factor will produce one fraction. So I'm going to have a fraction over x to the 9th. I'm going to have a fraction over 3x plus 2. I'm going to have a fraction over 3x minus 2. Okay, the question becomes, what goes in the top? Well, each of these guys is linear, degree 1, so that means the numerators are going to go down a degree. They're going to go down to degree 0, so the numerators will just be constants. Okay, so this is the partial fraction decomposition, okay, for this particular original fraction. Okay, this one was very tricky because you had to do long division before you started, and it was kind of a nasty long division. Okay, but you would proceed with this problem if you were solving for the coefficients. You know that this thing is equal to this left side. Okay, so the x cubed, let me see, let me get back up here. This is equal to the x cubed plus 4 over, if you factored out the bottom, let's see, this would be, if you factored out the bottom, that would be x times, well, you could factor this thing out, okay? But this is the original fraction you started with, okay? And you could go through the process again of solving for a, b, and c, okay? What I was trying to say is if you go back and you're going to try to do that, make sure you factor the denominator of the original fraction before proceeding. That will help you out a lot, okay? But we've done the hard work. The hard work was setting this one up.